Hello everyone, my name is Maria and my friend is Andy. We will present our last module about ternary diagrams. The goal of this module is draw a curve for the solubility of a liquid in two other liquids. The basic theory. The number of bases in a three-component liquid system depends on the solubility of the liquids and the experimental temperature. Suppose there are three liquids A, B, and C. A and B are partially soluble in each other. The addition of substance C into a mixture of A and B will increase or decrease the mutual solubility of A and B. In this experiment, only system that increase the solubility of acetone and chloroform will be considered. In this case, acetone and water and chloroform and acetone are completely soluble in each other. The solubility of liquid water in various composition of mixture of acetone and chloroform at constant temperature can be illustrated on a ternary diagram. The principle of describing composition in a ternary diagram can be seen in figures 1 and 2. For a mixture consisting of three components, the composition or the ratio of each component can be described in a equilateral triangle diagram called a ternary diagram. The composition can be expressed in terms of mass fraction for liquids or mole fraction for gas. Triangle diagram or triangle diagram is an equilateral triangle in which each corner is occupied by a substance component. The sides are divided into sides that represent the 100% portion of the substance that is at each corner. The points located in the triangular diagram represent the sum of the levels of each component. Types of ternary diagram are: one pair of partially soluble liquid is formed, two pairs of partially soluble liquid are formed, and three pairs of partially dissolved liquid are formed. The tools used are burette, pygnometer to measure the density, Erlenmeyer. The materials needed are acetone, chloroform, and water. The procedure. First, in a clean, dry, and closed Erlenmeyer, mix several kinds of mixture of acetone and chloroform which are completely miscible with each other with a certain composition. The volume ratio are 19 to 1, 18 to 2, 17 to 3, 16 to 4, 12 to 8, 10 to 10, 8 to 12, and 6 to 14 in 20 ml. And then titrate its mixture with water until it becomes cloudy. Write the volume of water used. Repeat step 1 and 2 by making several kinds of mixture of acetone and water that are completely soluble in each other with a certain composition. The volume ratio are same with the previous experiment. As much as 20 ml and titrate with chloroform until the turbidity appears just right. Write the volume of chloroform used. And then determine the specific gravity of its solution from acetone, chloroform, and water. Write the temperature during the experiment. The last, graph the solubility curve of the three liquids or ternary diagram.
So here is the data that we got. This is for the environmental data, and then this is the observation data of the using of pygnometer. Pygnometer is used to measure density. This is the observation data for titration of acetone chloroform mixture with water. While this is the observation data for titration of acetone water mixture with chloroform. So here is the data calculation of pygnometer. We can find the density of aqueous, acetone, and chloroform. Here is the number. And this is the example of titration data calculation. So basically, we are trying to find the mass fraction and mole fraction of acetone or water that is used to titrate. So from that example, we can make this table, and this table, and from this table, we can make a ternary diagram with the unit of percent mass and percent mole. This is the ternary diagram for acetone chloroform water mixture that we got from processing the experimental data. The left diagram is expressed in units of percent mass, while the right diagram represents in units of percent mole. From this experiment, there is three main discussion points to note. The first is chloroform and acetone are highly volatile compounds. Therefore, in this experiment, the mixture must be immediately covered with aluminum foil to prevent leakage. And then the second is, the titration that occurs in this experiment does not involve any chemical reactions, because the use of titration method is to determine the volume of the compound that have been added very accurately. Last but not least, the third discussion is about clear mixture is in one phase, while the turbid mixture is in two phases. So in this experiment, we look for the point where the composition of the mixture changes from one phase to two phases. The phase change occurred because of solubility, so that a dome is formed. There are also suggestions for better experiments, which are creating environmental conditions that inhibit the evaporation of acetone and chloroform, and then using more sophisticated equipment to get more accurate results, and the last, create a method that makes it easier for the practitioner to determine the turbidity of the mixture, for example with the help of light, so that the endpoint of the titration is more objective. That's all for our video. Thank you for your attention. We hope this video can be useful for you. Bye bye!